So today we will start lecture number 5, in which we will discuss the instruction set, what is instruction set and what is the instruction format, and also we will discuss the different types of instruction available to the computer. Okay, so first of all, the definition of the computer architecture is, it is defined as the study of components and their interconnection that forms a computer system. Okay, so an instruction set design for a machine is the primary concern for the architectural consideration. So whenever we design a computer architecture system, so then our instruction set is the primary consideration. Okay, now the complete collection of instruction that are understood by a machine is called the instruction set of that computer. Okay, now the instruction set is also called the ISA, that means instruction set architecture, and it is a part of a computer that pertains to programming, which is less or more the machine language. Then the program instruction set is actually the machine language. The instruction set provides command to the processor or to tell it what it needs to do. The instruction set consists of addressing mode, instruction, native data type, register, and memory architecture, interrupt, exception handling, and external IO. An example of instruction set is the architecture into Xchg instruction set, which is common to find in computer today, and different computer processor can almost use the same instruction set. Such as Intel Pentium and the AMD Athlon processor use nearly the same Xchg instruction set. The instruction set can be built into hardware of the processor or can be emulated in software using an interpreter. Okay, so as I have already said, the complete collection of instructions that are understood by a machine is called the instruction set. So now the third point is, it's tell the instruction set is the boundary where the computer designer and the computer programmer, this is the vital point. So computer designer is that who design the computer architectural design, and computer programmer is that one who perform the different type of programs and to tell the computer what to do the different type of functions. Okay, now much of the computer architecture is hidden from a high level programmer. That means in today's scenario, the programmer actually writes the program in C, Java, in this type of language. Okay, so this high level language, the computer architecture is actually hidden from the programmer of the high level programmer. Okay, so in the abstract sense, the programmer should not really care about what is the underlying architecture. He does not know about the architecture of the machine. The instruction set is the boundary, so that is the boundary. It is the boundary where the computer designer and the computer programmer actually sees the machine, same machine. Okay, the machine is actually visible to the programmer, it is the set of instruction. A programmer actually sees the machine as a set of instruction, and computer architect who design the computer actually design the instruction set. Okay, so this is the boundary. So before finalizing the instruction set of a computer, there is the different point to be understood. So the first point is flexibility to the programmer. Now a programmer wishes to have as many instructions. A programmer wants different type of instruction possible to the appropriate operations possible. Now this is not possible, because if we want to a computer architect to actually design the machine, if he or she design the numerous instructions for a particular machine, then the design of the control unit should be much complex. That Also the decoding circuit is a huge circuitry and the time, so that's why there should be an optimization to the number of instruction to the programmer and the speed and the complexity of the control unit design. So that is the flexibility to the programmer. Then the number of addressing modes. This point will be discussed later, where you will see for the particular instruction there are different addressing modes available. Now if all possible addressing mode are assigned to a particular instruction, then the number of instruction will be automatically higher for a particular machine, because for the move instruction, suppose for the move instruction there are 5 or 6 addressing modes available. Now if computer architect design the machine such that all of the addressing modes are assigned to this move instruction, or the all of the addressing modes are available, so the number of instructions should be higher. Also the design of the control unit would be much complex, so that should be kept in mind, or the optimization is required. And also the number of general purpose register. Next point is the general purpose register. Now the what is general purpose register? So all of you know that there is a B, C, D, E, H, L. These are the registers available to the 8085 microprocessor. These are called the general purpose register, which is available to the CPU. Now what is the purpose of this general purpose register? So the computation happens, or if the instruction uses this general purpose register, then the execution time will be less. But the problem is that the cost of the CPU will be increases. If the instruction uses memory, then the execution time will be higher, because the fetching of the instruction from memory is requires time, but the cost of the CPU will be much lesser. So there should be an optimization required for the number of general purpose register and the cost of the CPU. The programmer wants the more general purpose register, but that should not be assigned by the computer architect to the particular machine. Okay, next the system performance. So the system performance can be enhanced if less number of instruction is used in a program. Okay, if a programmer use the less number of instruction for a particular task, then the length of the instruction should be higher. If the length of the instruction is higher, the execution time will be higher. And if the programmer use the short program, then the instructions should be powerful, but the number of instruction for a particular task will be higher. So there should be some kind of optimization to the length of the instruction. If the length is higher, then the execution time will be higher, and obviously the program should be shorter, and vice versa. Next, the application. Now the application point of view, the the machine can be distinguished. If the machine is designed for the scientific purpose, then the floating point arithmetic without the precision will is heavily degraded, whereas for the entertainment, computer must have the multimedia operation. So that is the optimization point of view. Okay, so sorry. So next is the instruction format. Now in the case of the okay, so next is instruction format. So in this case, the bits of instruction are divided into group of fields. These fields are known as the instruction format. Now in instruction generally composed of 3 fields. First one is your opcode, second one is your address, and third one is your mode. This is the 3 field of an instruction, any instruction, general instruction. Now opcode, mode, and address. Now the opcode is actually field which states the operation to be performed. This field defines the various processor operations such as add, subtract, complement, etc. So just by seeing the operational code, one can define what type of operation is to be performed by that type of instruction. Now the address field is designated a memory address, processor address, where is to be processor or data is to be fetched and perform the instruction type. Mode is actually specified the method to get the operand and effective address, where is to be fetched the register, where is to be fetched directly, or where the data is to be fetched indirectly. That is defined by the mode of the instruction. So that is the 3 part. Okay, operational code, address, and the mode. Okay, and next is instruction set. Now instruction set, I have already defined the instruction set. is actually the particular machine is it particular. That means the instruction set of a processor is a collection that defines the all instruction. A complete instruction set is often referred to as the instruction set architecture. Okay, so an instruction from the set alone can be used the programs that run the processor. Instruction set of a processor has the following characteristics. Following characteristics means completeness, completeness, efficiency, regularity and compatibility. What is the meaning of that? Completeness is actually what should be able to construct a machine language program to evaluate any function that computable using reasonable amount of memory and space. So instruction, where we design an instruction, there should be some sort of provision. It is also the machine language in the hardware point of view. So that instruction should be compatible with reasonable amount of memory space. Okay, whatever instruction we are designing to perform a particular task, that instruction or the instruction set must have a memory optimization. It should be a finite amount of memory. Efficiency, frequently required function can be performed rapidly. That means there in the instruction set, if we use the instruction add, also instruction multiplication, so that is less efficient machine, because the multiplication program can be performed with the help of this add operation using repeatedly. So if we use only instruction set for a particular machine, only add, then the efficiency of that machine will be higher. Regularity, the instruction set should contain expected opcode. Expected opcode means, suppose an instruction set, if you use add, sub, multiplication for mul, this command actually tells the programmer easy amount of memorization. That means a programmer can memorize this. That means just by seeing this opcode, one can easily identify this is the add operation, this is the subtraction operation. If we use the command like D, B, C, like that for the add operation, so that is hard to identify for the programmer also, and to memorization point of view also. That is not the regularity point of view. Okay, so next, compatibility. To reduce the hardware and the software design cost, instruction may be required to be compatible with those of the existing machine. So the hardware and the software design cost and the instruction for a particular machine, that should be compatible. Okay, so next is the instruction type. So instructions in an instruction set are classified into different types on the basis of the following factors. First one is your opcode. So opcode, first one is your opcode type of operation to be performed by the instruction. And instruction set are different. In the instruction set, different type of instruction are available depending of the opcode. Different opcode has different instruction. Next one is your type of data. So type of data may be binary, may be decimal, and depending on that, different instruction had to be devised. Next one is your operand location. So operand location, it can be in memory, can be in register, and depending on that, different type of instruction are available. Next one is the operand addressing. The method of specifying the operand location. That means that depending on the addressing mode, different type of instruction are available. Next one is your instruction length. So 1 byte, 2 byte, etc. There are different type of instruction available which are 1 byte, and also 2 byte, 3 byte, etc. And also we have discussed previously that the instruction can be also be classified depending on the 0 address, 1 address, 2 address, 3 address instruction, depending on the instruction length. So this is the classification depending on the instruction length. So depending on the instruction length, the number of address field, the 0 address, 1 address, 2 address, and the 3 address instruction are available. So no two computer have the same instruction set. Okay, almost different instruction set. Okay, and but the actual operation are available in the instruction set are not very different from one computer to the another. That means there are different computer have different instruction for the same add operation. That means the operation may be same, but the instruction available to the different computer to another computer is different. Almost every computer has the same unique instruction which attract the many programmers. Today's era, the generalized instruction set are available almost, so that it can attract the programmer. One can actually knows the one instruction set, it can be useful for the different machine. That is more viable. So the computer architects gives the considerable attention to the framing of the instruction set, since it involves both programmer and the computer machine. So taking into account some of the instruction of the several popular computer, the instruction can be classified in the following types. So these are the computer instruction types. We will discuss one by one that. So first one is your data transfer instruction, and so is your data transfer instruction. Second one is your arithmetic instruction. Third one is your logical instruction, set of logical instruction. All these are set of instruction. Next, program control instruction, and next the input output instruction. Data transfer instruction actually compose the copy of information from one location to another. It is actually tells the data transfer. Arithmetic instruction actually composed of set of instruction which perform the operations on a numerical data, also perform the different type of arithmetic operation. Logical instruction is includes the boolean and non-numerical operations. Program control instruction is the branch instruction. Okay, that means jump, anything, a jump with carry, no carry, like that. So input and output instruction which cause the information to be transferred between the main memory and the IO devices with the help of the in instruction or the out instruction, like that. Okay, and so this is your data transfer instruction. Different data transfer instruction are available is this. Okay, first one is your move, second one is your load, store, exchange, clear, set, push, pop. These are all the data transfer instruction. So we will discuss the different type of instruction of this. What is the function of this? It is actually written. Move is actually copy word and block from one source to destination. Load is actually copy word from memory to processor register. Load is actually from memory to register. Store is actually from register to memory. Exchange is, that is name implied, exchange the data or swapping the data. Clear means all zeros. Set means all ones. And push or pop is actually zero instruction length, classification of the zero instruction length used in that type of instruction. Okay, transfer what from the top of the stack. It is actually related to the stack operation. Okay, so first we will discuss the move instruction. Okay, sorry, move instruction, and how this move instruction is with the different addressing modes. That I have said that one instruction can be used with the different addressing mode, and if the number of instruction for a particular instruction, different addressing modes and numerous addressing modes are available, so that is a optimization for the flexibility to the programmer. Is a control unit design is very much complex. So here we will address this particular move instruction is used as a different addressing mode. Okay, that is be interesting. So first one is your immediate addressing mode. Immediate addressing mode is tells that the number copied to the register is immediate. That means data is immediate. That means here you can see that move AL to 10, comma 10. That means 10 is the data that is immediately loaded into the register. Copy. Okay, moving to the data 10 to the AL register. So that is the simplest move command and easy to understand, and is the classification of the immediate category. Next one is the direct register. So move AL comma BL. So here data is not defined directly or immediately. Here data is defined directly. That means whatever the content of BL, that is moving toward the AL register. That means one register content is moving to the another register content, but directly, okay, within the register. That's why it is called direct register, not immediately. Direct memory. So move AL 50, copy from RAM location into AL the data from address 50. The square bracket actually defines this square bracket actually defines this is the square bracket data. That means the data within that memory address 50 is loaded into the register AL. Also from register AL data is loaded into the memory location 50. So that is the direct memory. Okay, so this is one type of addressing mode. Next is an indirect. Indirect means this is your first register, this is your second register. So whatever the content of that register, suppose BL contain 50, so 50 is pointing to the memory location, and what is the data of that memory location, that is loaded into the AL. So that is the indirectly, that means BL, first BL register contain 50, next the content of that memory address, it is pointing to the memory address 50, and the content of the memory address 50 is loaded to the register AL. So that is the indirect mode of addressing mode. So next one is your index addressing mode. So as the name implies, the index addressing mode, this is move AL 20 plus BL, that means this is the offset. So suppose BL contains 50, here offset is 20. Okay, so the memory content of the 70, memory location 70, whatever may be the content, that is loaded into the AL. So that is called the index. Here the index addressing mode, offset is depends, that offset is here 20, and the inversely that is true for the AL, whatever may be the content of the AL, that is moving to the memory location. Suppose if BL is 50, that is moving to the memory location 70. And base register means as the SI is defined. So this is in place of this 20, this is offset. Here offset is defined in terms of SI. So whatever may be the content of this SI, that of same operation has to be performed. Suppose SI contains 20, BL contains 50. So the content of that memory location 70 have to be copied to AL. So same operation has happens here. So instead of this 20 offset defined in the previously index register, here's the base register. Base register is actually here, BL is your base register, and it holds the starting address of the data table, that means source index. Source index means uses the index records from the data table. So the addition of these two, whatever may be the content, that is moving to the, in case of an index register, the perform the same operation. Here's the base register is used, and here the index register is used. Okay, so here we have defined the different type of addressing mode for a particular single instruction. Okay, and it is defined almost for the every instruction. Okay, we will not discuss that, but like the move instruction, every instruction have different addressing mode depending on the type of data available. Okay, so if we next one is your load. So load is actually moving the data from the, there is two instruction, load and store. Okay, so 1 minute. Okay, so this is load and this is store. So load is actually is a symbolic opcode, is used for transferring data from register to memory. It is used for store the data from register to memory, and store is used for transferring the data from memory to register. This is the two difference between that. And exchange means if we want exchange, as the name implies, swiping the data, that exchange R1 comma R2. So the content of these two are exchanged. And in input output we will discuss in the input output section. So next are push and pop. So push and pop is used for the stack addressing mode. So suppose I have written zero address instruction, push A. So this is the stack. So the top of the stack contains the A, whatever may be the value. Suppose the value of A is 10. Next, if we use push B, so value of the B is pushes to the top of the stack. Suppose it is contains B20. Next we perform the addition, add. So whatever may be the content of A and B, that is added, popped and added and storing in the top of the stack. That means 30 is storing here. Okay, so that is the structure of the stack. We defined a stack. First push A means A has been pushed here, whatever may be the data that is pushed here. Push B, whatever may be the data that has been top of the stack. Top of the stack is defined TOS, top of the stack. So top of the stack contains this, then addition. These two are popped and added, and the 30 has been pushed into the top of the stack. So that is all about the data transfer instruction, input and output section. In the input output section, we will discuss these two instructions in the input and the output section. Okay, So we will in the next class we will discuss the arithmetic instruction and also the program control instruction and the IO instruction and also the logical instruction. Okay, so in this lecture we discussed only the move, and also we have seen the different addressing mode associated with move, and we have not shown the addressing mode for this all type of instruction, but it is true for all this instruction that different addressing modes are available for the this instruction also. Okay, and load, store, exchange, and clear and set. Clear and set is actually transfers word of zeros to the destination, so we have to reset the data. Whenever we want to reset the data of a particular location, we use the instruction clear, and whenever we want to set the particular destination data, then we use the instruction set. And push and pop and we already discussed. Okay, so in the next lecture we will discuss the other instruction.